Hello everyone, welcome back to the channel. It's time to give you a quick little update on what I've been doing during the last week. This time I've tried to put together a script, so hope you guys enjoy. Starting off from where we last left off, the summon tiles now actually summon monsters. The level of these monsters are determined by the level of the dice that spawns it. The levels go from 1 to 4, and the higher the level, the higher the health points. For this to work, I utilized a base monster class that contains all the core functionality a monster might need, but then can be specialized for children that are spawned into the world. This allows me to keep a clean code base by procedurally generating each monster, just like the dice. The skeletal meshes, names, materials, levels, and anything specific to each monster is determined through a predefined data table. Speaking of levels, the game now features summon crest rarity just like in the anime. Summon crests decrease in number as the level increases, starting at 4 crests at level 1 and dropping to just 1 crest at level 4. Since I'm certain to be working with just 4 possibilities here, I simply hard-coded a select node. Also, summon tiles can now only be called if you roll 2 or more summon crests of the same level. This means the player has to be strategic in picking their dice. If they pick all level 4s, then the chances of them rolling 2 summons are very low, unless they have Lady Luck by their side. Another change worth mentioning in the dice department is the changes to their visuals. Now the entire dice is color coded to match its level, as opposed to each crest having its own color. And to make crests more distinctive and important, I switched their placeholder text for proper in-game icons. This makes the whole system feel a lot more cohesive and very nice. Next off, monsters now utilize the pathfinding function as a determiner for its movements. In the previous devlogs, I briefly hinted at the existence of a pathfinding function but never really showcased it, so here it is. This function once again is a direct replica from Alex's turn-based series, so if you're interested, do check him out. For this project, however, I extended upon the base pathfinder. The tiles now have various new states that indicate if it's currently occupied, if it's a path, or a path route. I also tweaked the find neighboring tiles function to account for the occupied tiles and change the paths accordingly. The pathfinding also takes movement points into account when planning a path. This is done by simply trimming the path to fit the exact number of movement points available to the player. Since the path is an array of tiles, we can simply splice them at index 0 with the length of the available movement points. A simple solution for limiting the player movement without performing a lot of unnecessary checks. To finalize, the monster's location is set to the target location of the path. As of now, the monster teleports to the new location, but we'll fix that soon enough. One change that may seem unworthy of mention but is something everyone should consider is to limit their tick function. In my previous devlogs, I mentioned ticks can be quite expensive depending on the code you're running in it. If you have huge calculations running every 10 milliseconds, then you're guaranteed to get bogged down. In my case, the code called every tick was getting a little too out of hand, so I switched it for a custom event that gets called every 0.045 seconds via a timer by event. Now the jump from 10 milliseconds to 45 milliseconds doesn't seem too big, but I simply couldn't go any higher without affecting the playability of my game. In your case, it might be different though, so start high and then go incrementally lower. Next up, players can now use monsters to attack enemies with the introduction of the attack action. Since monster actions are an important part of the game, I moved them to their own separate UI. There are only 3 actions in there for the time being, but they are already set up in a scalable manner. The selected monster can only attack others that are in its range, that is, all adjacent tiles. If the enemy is too far away, the player must first move to a valid location and then commence the attack. The attack mechanism also takes attack points from the crest pool into consideration. For the time being, the cost of every attack and damage is just one action point. But in the future, I'd like to have various cards that deal various damages to various enemies. Once an enemy has been killed, the occupied status of the corresponding tile is also removed. This already adds a challenge to the game. You must first take care of the enemy summons in order to reach their master, but at the same time strategically manage your monsters to attack or defend. Remember, the rules of this game are quite simple, and so are the core mechanics, but it's a mind game involving limitless possibilities. Moving on to the last update, moving monsters through a path. Getting this to work took me a lot of time, so I'm really proud of how it turned out. Like before, I'm calling the movement code through a custom event instead of the tick function. I initially did everything in the tick method, but later switched to using a timeline. In the timeline update, we looped the monster's current location to the path's first tile location. Once the timeline is complete, the first tile is removed from the path array and the event is called again. This recursion goes on until the path array is completely empty. Well, that's pretty much it for this week's episode. I'm really happy about the progress I've made thus far. I've come from creating an empty UI project to creating at least some of the core mechanics in just about a month's time, and I'm really excited for more interesting things to come by. As always, thank you for watching. If you guys enjoyed my work, consider subscribing, and you can also directly support me on Patreon. With that said, I will see you guys in the next episode.